Alrighty, so when we are going to find domain and range, we want to look at how far to the left and to the right. So we're looking at the x values. So what's the furthest left the function goes, and what's the furthest right the function goes. So this function looks like this, and the furthest right it goes is right here. It doesn't go any further right than that, and we want to see what is the x value at this point. So the x value right here is -2. So we'll start at -2. And then as we move along, it moves to the right, and the last place it's at the right is this value. And we want to see what is the x value right here. Well, that's 1, so it ends at 1. Now the endpoints are both closed, so we're going to have brackets here at the endpoints. The range is going to be the same thing, but the up and down, the y values. So we want to know what's the lowest point of the function. So the lowest that the function gets is this point right here, but now we're looking at the y value. So the y value right here is 0. And then we want the highest part of the function, which is right here, and the y value there, which is 3. And again, they're both closed, so they should both be closed. So let's do that over here with b as well. So the furthest to the left the function goes is this right here. So the x value here, because domain is x values, is -2. And the furthest to the right the function goes is over here, and the x value right here is 1. So the ending value is 1. And we want everything in between that, so we want to write it as an interval, but on this endpoint at -2, it's open, and at this endpoint 1, it's closed. The range is the same thing but up and down, so the y values. So the lowest value of the function is right here, and the y value right here is -1. So the lowest value will -1, and then it'll go all the way up to the highest value, which is right here, and the y value here is 2. So everything from -1 to 2. Again, at -1 down here, it was closed, and at -2 up here, or I'm sorry, at +2 up here, it was open. So we have an open parentheses. These values here, we're trying to find the function values at these x values. These are x values. So we want to go to the graph and look at what is the function when x is 0. So here, x is 0, right here. So we want to look at where the function is. Well, our function is right above us, so we'll go up until we get to the function. And at that point right there, the y value is 2. So that will be our answer here. So at this point here, this point, the x coordinate is 0 and the y value is 2. So when x is 0, y will be 2 is your answer. And then at 1, we're going over here to when x is 1. We want to see where our function is. We'll go up. Our function is right here at the y value of 3. So over here on b, if we're trying to find f of 1, we're going to go to x equals 1, which is right here. Our function is below us this time, so we'll go down to where the function is, and we look at what the y value is there, which is -1. And then at x equals -1, we're going to go over to -1 on the x-axis. Our function is above us, so we'll go up to the function, and we'll look over, and it's at a y value of 1. If our graphs go off the graph, we're going to assume that they have arrows on them, like this, and are going on forever. So that affects our domain and our range. So our domain here, if we ask ourselves how far to the left does our function go, well, it's moving up here, but it's also moving left, and it's going to keep moving left forever and ever and ever. So it's going to keep going this way forever and ever and ever to -infinity. It's never going to stop. And then for the right, it's going to be moving up and to the right, up and to the right, up and to the right, forever, ever, and ever. It's going to move this way to the right forever, so it will never stop. So our domain will be -infinity to infinity. Now if we look at the range, we're looking at what's the lowest value of our function. And remember, these were x values that we were just looking at for domain. So our range is y values, and we want to know the lowest. So the lowest point on the function is right here, and it's at -4, and there's a point there, so it's included because it actually reaches that. It's not an open circle. But then the highest value, our function goes up and up forever on both sides, so it's never going to stop, so we'll go to infinity. Our x-intercepts, or zeros, are where we cross the x-axis, so we're going to look at those. We cross the x-axis at these 2 points, and when we write x-intercepts, we will be writing points. So we want to know the x and y coordinates of this point right here. So this point right here, the x and y coordinates, the x is 3, and the y is 0. So our first x-intercept would be the point 3, 0. That's not an interval, that's a point. And then our second x-intercept will be here at -1, so that'll be -1, 0. So this point right here, the point is -1, 0. And then for our y-intercepts, we're looking at where it crosses the y-axis, so that's right here. And the coordinates of that point will be 0 for the x and -3 for the y. So again, that's not an interval, that's just the location of that point. 0, -3. So let's go ahead and do that over here with b. For our domain, we'll be looking at how far to the left and to the right this function goes. So it's going down and to the left over here, and it's going to keep going down and to the left forever. And then on the right, it's moving to the right, down and to the right forever. So it's going to keep moving right forever. So our domain will be -infinity to infinity. Our range, the lowest value, it's going to keep going down forever, so it will be -infinity. But the highest value, it does not go beyond 6. So the highest value will be 6. And there is a point there, so it will be included. It's not an open circle. Our x-intercepts, there are 2 of them where it crosses the x-axis. That first one here is at -4 for the x, 0 for the y. And here it's at 1 for the x and 0 for the y. And then our y-intercept is here at 4, where it crosses the y-axis. The x value there is 0, and the y value is 4. Alright, so now we're going to talk about increasing and decreasing, and we'll refresh on domain and range. So increasing is when a function is going up when you move from left to right. Decreasing is when a function is going down when you move from left to right. And constant is when it's staying flat from left to right. The most important thing here is that when you're describing these, our intervals have to be reported with x values. We only want to use x values for increasing, decreasing, and constant. Domain is x, range is y, and increasing, decreasing, and constant are x. So we'll start here with the domain and range. So this guy continues forever. So it's going to go down and to the left forever. So it's moving to the left forever. So the domain will start at -infinity. And then it's going to go down and to the right forever. So we go right forever to positive infinity. For the range, you're looking for the lowest value. So again, it's going to go down forever. But the highest value, it never goes above 5. So we reach 5. There is a point there. So that should be included. When we're doing increasing, decreasing, and constant, we're going to be tracing the function from left to right. So let's start on the left side. If we start on the left side here and trace my function, it is going up. So that means it's increasing all the way until this moment right here. So it starts at -infinity, because we would say there's not going to be a point all the way to the left where it starts. It's going to keep going. So there's not a place where it starts increasing. So it will start increasing at -infinity, because we're looking at the x values, okay? And then it's going to be increasing, increasing, increasing until this point right here. We don't want to say it stops increasing at 5, because that's a y value. We want to look at the x value. So the x value where it stops increasing is at -1. So we will say till -1. Always in open parentheses when it changes from increasing to decreasing. Then it starts decreasing from -1 all the way, and it's going to keep going right forever to positive infinity. So it'll be decreasing from -1 to positive infinity. There is no place where this one is constant. It would have to be flat. And then for these values for f of 0, we're looking at when x is 0. What is the function? Well, it's at 4. And when x is 2, what is the function? Well, it's down here. Can't really tell because I have too much going on here. Let's erase this. So when the function was at 0, it's up here at 4. When x is 2, down here, our function is below us, so it's at negative 4. Alright, so when we look at the domain and range here, we're going to start with the domain. We're going to look at left and right. How far left does the function go? Well, when it goes off the page like this, we're going to assume it's going on forever. So this function goes to the left and it's never going to stop. So the domain will go to negative infinity. And then this function goes to the right forever and it's never going to stop. So it'll go to the right to positive infinity. These are x values. For the range, we're looking at up and down. How far up and down does it go? Well, the very lowest point of the function is right here. But we want the y values here for the range. So what's the y value here? Well, it's 0. So the range stops at 0, and it does reach that. There is a dot there. Even though it doesn't say there's a dot, there's an assumed dot. It's not an open hole. So it is included. And then how far up does the function go? Well, it keeps going forever and ever up. So that will be up to positive infinity. Now when we're doing increasing, decreasing, and constant, these should all be used for describing with x values. So here when we're increasing or decreasing, we're going to look from the left and the right. So if we start on the left and move to the right, my function is going down until this point. Now the y value here is 0, but we want to use the x value. So we're going to say until 2 because the x value is 2. So starting at negative infinity and going till 2, it's decreasing. So we need to put that on the decreasing line. And then going from 2 to infinity, it's increasing. And there's nowhere where this is constant. When x is 1, our function is up here and the y value is 1. When x is 2, our function is sitting right here on that spot, so the y value is 0. This graph here is going off the page to the left and to the right forever. So to the left and the right, domain will be negative infinity to infinity. Up and down though, however, it only hits one value, and that's 4. So we would say the range is just 4. There's no places where this is increasing, and there's no places where this is decreasing, because this is always staying constant. And it's from everything from negative infinity to positive infinity that's staying constant. When I plug in x equals 3, I go up to the function, and it will be at the y value of 4. And 15 is not even on the graph. It's all the way out here. But that's okay because we know our function will still be at 4 all the way out here. So even at 15 all the way out here, the function will still be at 4. For number 4 here, our domain, how far left does the function go? Well, it keeps going left down to the left forever. And then how far right does it go? Well, it keeps going right down and forever. So our domain will be negative infinity to infinity. Our function goes down forever. So the range will start at negative infinity. But it doesn't go up forever. The very last y value, the highest y value is here. And this is at 3. But it is there at that value, so that should be included. Now if we go left to right, and we start here, the function starts by increasing. So from negative infinity till this point right here, it's increasing. But this point right here, remember you want to use the x value, not the y value. So don't use the 2. That's the y value to describe where it stops. So it stops increasing at negative 8. Then it starts decreasing from negative 8 until this point. And this point right here, the x value is negative 6. So it'll be decreasing from negative 8 to negative 6. Then it stays constant from negative 6 until this x value, which is negative 3. Then it's increasing from negative 3 until this point, which is just a little bit further, so negative 1 or negative 2. And then it's constant again from negative 2 until infinity. When we're finding the function values here, we're going to look at f of negative 8. So when x is negative 8 here, we look at where our function is. It's up above, and the y value there is 2. When we look at 2, our function is also up above, and the y value there is 3. This last one is a little tricky. For the domain, we're going to start with the furthest left. So this is the furthest left, which that's negative 5. It should be closed because there's a closed circle there. And then it moves to the right here. It's open there, but it closes again down here. So we don't need to skip over anything. And then it keeps going, and then it's closed here, but then there's nothing here in between. So we need to stop the domain. The domain stops right here at negative 1. Closed, because the closed circle up here. And then there's nothing in between here. So the domain starts again at 1 and goes to 5, because that's the furthest to the right. As far as the lowest value is at negative 4 for the y, and the highest value is at 6. For increasing, it's increasing from here to here, and since those points are on the end, you can put closed brackets. So this will be at negative 3 and negative 1. Then it's decreasing from here to here. So this is from 1 to 3. Because the 1 is on the end, you'll use a bracket. And then it's increasing again from 3 to 4. I'm sorry, 3 to 5. This is at 5. Use a bracket. And then it's constant from negative 5 to negative 3. Since the negative 5 is on the end, you can use a bracket. And then for the function values, at 3, the function is up here at 2, and at negative 4, the function is up here at 1.